At what time of day is Greyline propagation most likely to occur? A. At sunrise and sunset. B. When the sun is directly over the location of the transmitting station. C. When the sun is directly overhead at the middle of the communications path between the two stations. Or D. When the sun is directly above the location of the receiving station. Answer A. At sunrise and sunset. And now, VHF, UHF, and microwave propagation. Under normal conditions, tropospheric bending causes VHF and UHF radio waves to be returned to the Earth beyond the visible horizon. The radio horizon is approximately 15% further away than the visual horizon. Signal fading or picket fencing are common results of multipath. Multipath is where several components of the same transmitted signal may arrive at the receiving antenna from different directions. The phase relationship between these multiple signals may cause them to cancel or to reinforce each other. Transequatorial propagation is where the azimuth pathway of signals is bent based on large land masses such as North or South America. Auroral propagation occurs when VHF radio waves are reflected from the ionization created by the auroral curtain. It is a VHF and UHF propagation mode that allows contacts up to about 1,400 miles away. The possibility of auroral propagation decreases the further you are away from the geomagnetic North Pole. Actually using auroral propagation is most common on 10, 6, and 2 meters. Auroral contacts have been made on frequencies as high as 222 and 432 megahertz. As a meteoroid speeds through the upper atmosphere, it heats up and begins to vaporize as it collides with air molecules. Radio waves can be reflected by the ionized trail of a meteor. The concept of moon bounce is fairly straightforward. Stations that can both see the moon at the same time can communicate by bouncing VHF or UHF signals off the lunar surface. Those stations may be separated by nearly half the diameter of the Earth, a distance of up to 12,000 miles. What is transequatorial propagation? A. Propagation between two mid-latitude points at approximately the same distance north and south of the magnetic equator. B. Propagation between any 2 points located on the geomagnetic equator. C. Propagation between 2 continents by way of ducts along the magnetic equator. Or D. Propagation between 2 stations at the same latitude. The answer is A. Propagation between 2 mid-latitude points at approximately the same distance north and south of the magnetic equator. Which of the following frequency ranges is well suited for meteor scatter communications? A. 1.8 to 1.9 megahertz. B. 10 to 14 megahertz. C. 28 to 148 megahertz. Or D. 220 to 450 megahertz. The answer is C. 28 to 148 megahertz. What type of receiving system is desirable for EME communications? A. Equipment with very wide bandwidth. B. Equipment with very low dynamic range. C. Equipment with very low gain. Or D. Equipment with very low noise figures. The answer is D. Equipment with very low noise figures.